Okay, so in this lecture we will discuss about half adder. We will discuss about half adder. But before starting this topic, we have to know that what is half adder. So basically all digital circuits are divided into two types. All digital circuits is divided into two types. One is known as combinational circuit, one is known as combinational circuit, and the second one is known as sequential circuit. Okay. Now, what is combinational and what is sequential circuit? Suppose I am making a block diagram. This one is the block diagram. This block diagram represents a circuit. If the input that is provided in the circuit is digital in nature, that means it is in the form of 1 and 0. So I am calling this type of circuit, I am calling this circuit as digital circuit. This digital circuit may be combinational, this digital circuit may be sequential. Now, how can we identify it as combinational or sequential? Okay, so from this port we are providing input, and from this port we are getting the output. Okay, now this type of digital circuit is known as combinational circuit CC when and only when the present output is depends on the present input. Okay, suppose here I am checking a block diagram. Here I am checking a block diagram. Here n different inputs are there, and accordingly we are getting m different output. Okay, so each output is getting when present input is provided to the circuit. Okay, so I repeat the definition of combinational circuit. Combinational circuit is that in which the present output is depends on the present input only. Okay, now what is sequential circuit? Now what is sequential circuit? Sequential circuit is just sequential circuit is that. Now I am making a block diagram. Here I am making a block diagram. Here, this type of digital circuit is known as sequential circuit if the output is not only depend on the present input but it also depend on the past output. Is it clear to all of you? So the circuit in which the output is depend on the present input is known as combinational. If it is depends on the output as well, then this type of circuit is known as sequential circuit. Okay. Now there are various examples of combinational circuit. Out of them one is adder. Out of them one is adder. Now this adder circuit. Now this adder circuit. This adder circuit is a circuit which is used for the arithmetic addition. Is it clear? Now what is arithmetic addition? If I am adding two bits 1 and 1, so what we are getting in the output? We are getting 0 as sum and 1 as carry. So this type of addition is known as arithmetic addition. Okay, but when I am taking 1 or 1, it means that I am taking a OR gate. Here I am providing two input 1 and 1. We know that OR gate is responsible for the addition. So when both inputs are 1, same as here, when both inputs are 1, at that time we are getting output as 1 only, not 1 0. So this type of addition is known as logical addition. This type of addition is known as logical addition, and this type of addition is known as arithmetic addition. This type of addition is known as arithmetic addition. Is it clear to all of you? So a device that is responsible for arithmetic addition is known as adder, and that the device that is used for the logical addition is OR gate. Okay. Now this adder is divided into two types. There are the two types of adder. One is known as half adder and another one is known as full adder. Here in this class, in this lecture, we will discuss about half adder only. Okay. Now what is half adder? Now what is half adder? Half adder half adder is nothing but a circuit in which there are two inputs and two outputs. Okay. Half adder is a circuit in which there are two inputs and accordingly we are getting two outputs. One output as sum and another output as carry. Okay. To analyze the whole characteristic of half adder, we are making a table known as truth table. We are making a table known as truth table. Now what is truth table? Truth table is that in which is used for the analysis purpose of digital inputs. Okay, here I am analyzing half adder. In half adder only two inputs are there, that's why I am taking two inputs A and B, and we are getting two outputs, so I am taking one output as sum and another output as carry. Because of two inputs there are four possible combinations: 0 0 0 1 1 0 and 1 1. So when 0 and 0 are added, so at that time we are getting sum as 0 and carry as 0. But when 0 and 1 are added, so at that time sum is 1 and carry is 0. Third condition is same as second. So we are getting the same input, same output. And the last condition, when both inputs are 1, so we are getting sum as 0 but carry as 1. Okay. Now by using this truth table, this truth table is same as this truth table that is mentioned here. Okay. To analyze this truth table, we need its equation. Now, first I have to calculate equation for sum. How to calculate? How we can calculate the equation for sum? We check the column of sum in which where 1 is coming, and when we find out the 1, so we are taking the input combination, successive input combinations. Okay, so here 1 is given in the sum column, so its corresponding input combination is 0 1, that is A bar B. Okay, now more another one is there, so accordingly we are getting second combination as 1 0, so we can write it as AB bar. So this combination can also be written as A XOR B. This combination can also be written as A XOR B. Okay, so in this notes you can see here one Karnaugh map is used for the simplification purpose, but by simple analysis we doesn't need a Karnaugh map for its simplification. Okay, now we have to find out the equation for carry. To find out equation for carry, we are checking the carry column where 1 is coming. Here 1 is come, and accordingly we will take the input combination. Here input combination is 1 0, that's why value of C will be AB. C equals to AB. So these are two equations. One is sum equals to A XOR B and carry equals to AB. You can find out we can also use Karnaugh map for its simplification, but it doesn't need here because the Boolean expression is very small, so we doesn't need any Karnaugh map of or any other methods of simplification, isn't it? So last one, by using this equation, we can implement the logic diagram. We can implement the logic diagram. Now what is logic diagram? We can implement logic diagram. Logic diagram. Now what is logic diagram? Logic diagram is that is drawn by using logic gates only. So here sum equals to A XOR B. It means that we need one XOR gate where one input is A, another input is B, and we are getting sum here. Same as when we are taking these two inputs in the AND gate, so accordingly we will get carry in the output side. So this one is the logic diagram. You can find out in the notes. This one is the logical representation. Okay, so this one is all about the half adder. In next lecture we will discuss full adder also. Okay, thank you so much.